sir.
Yeah, okay. So in today's lecture, we are going to discuss about fuel injection systems of CI engine. So today's lecture is about fuel supply and fuel injection in CI engine. The outline of the presentation is like this. We'll start with the difference between SI and CI engine combustion. Then we'll go to different types of flames, and we'll discuss about fuel supply system in CI engine, its layout. And then we will be discussing about what are the requirements for fuel injection system in the case of a CI engine. Then we will discuss about the various classifications of fuel injection in CI engine. And finally, the different types of fuel injection in solid injection system, right? This is what we are going to discuss today. So let us start with the difference between SI and CI engine combustion. In the case of, if you see the diagram here, this is a SI engine, spark ignition engine, where let us consider the conventional method where the air fuel mixture will be mixed outside the engine cylinder, and the air fuel mixture is going to enter through the intake valve. Okay. In the case of a carbureted engine or in the case of a manifold fuel injection engine, the air fuel mixture, the mixing of air and fuel will take place in the intake manifold, and the air fuel mixture enters into the engine cylinder during the suction stroke as the intake valve opens. Okay. So inside this we are going to have completely air fuel mixture. In the case of SI engine, we are going to have air fuel mixture inside the engine cylinder, and when the spark is introduced after the compression stroke completes, when the spark is introduced, the flame propagates and the complete combustion of the air fuel mixture takes place. And finally, during the exhaust stroke, the products of combustion are going to leave through the exhaust valve. Okay, this is what happens in SI engine. Whereas in the case of CI engine, if you see, only air enters. In the case of CI engine, only air enters through the intake valve, and after compression stroke, fuel is injected through the fuel injector. This is fuel injector. So fuel is injected. So when the fuel is injected, so it has to mix with the air, and also combustion has to take place. Both the ignition also starts and mixing of the air fuel mixture also will start. So at the extreme end, if you see, you will find air alone, right? So this is the main difference between the combustion when it takes place in SI and CI engine. So in the case of CI engine, fuel is injected after the compression stroke. Fuel is injected, or just about to complete the compression stroke, fuel is injected using the fuel injector, and the mixing and ignition of the air fuel mixture starts. Mixing and parallelly ignition of the fuel starts, because the temperature of the air is at the auto ignition temperature of the fuel. So as soon as the fuel is sprayed into the engine cylinder, the combustion starts and the flame front propagates through the air fuel mixture. Closer to this region, you will find the rich mixture, and then subsequently in the later regions, you will find the lean mixture, and finally there is a chance for having only air alone. Okay, this is how it happens in the case of CI engine. But in the case of SI engine, when the spark is introduced, ignition occurs and the flame front propagates through the air fuel mixture. Okay, so this is the difference between the combustion in SI and CI engine. Okay, in the case of CI engine, mixing and ignition occurs parallelly. Okay, so now coming to the different types of flames. In general, we classify there are two different types of flames. One we call it as pre-mixed flame, and the other one we call it as diffusion flame. Right? In the case of pre-mixed flame, the fuel and the oxidizer. In the case of pre-mixed flame, fuel and oxidizer are mixed well before the combustion process takes place. Right? So the mixed fuel and air, it will undergo combustion. Okay. So this is what happens in the case of SI engine, a conventional SI engine. We are going to have pre-mixed flame, and there is another type of flame called diffusion flame. In the case of diffusion flame, what will happen is the air and fuel are separated. Okay, and only during combustion, this air and fuel, they will come in contact, right? So in the case of you consider the case of a candle that is burning. Now this has the fuel, and outside the flame we are having the air. So the combustible vapor, right? Hydrocarbon vapors from the candle, and the air it mixes and it undergoes combustion. So this we call it as a diffusion flame. Now you consider the case of our CA engine. In the case of CA engine, at the core of the flame, we are going to have pre-mixed flame, right? Because here this air fuel mixture is available and the flame front propagates. Whereas at the outer periphery, air is present, right? And the fuel that has been sprayed, when it is going to spray it is going to propagate through the air. It is going to propagate through the air. So thereby it mixes and the combustion takes place, and only during the combustion the fuel and air they come in contact. Okay. So in the case of CA engine we are going to have both pre-mixed flame and diffusion flame. So both will be there. So in the case of CA engine, we are going to have both we are going to have combination of pre-mixed and diffusion flame, right? Coming to the schematic layout of the fuel injection system in the case of a CA engine. So in the case of CA engine, fuel tank will be there, right? This is the fuel tank, and from the fuel tank, the fuel is pumped with the help of fuel supply pump or fuel feed pump. Okay, so a dedicated pump will be there which will be supplying the fuel from the fuel tank. That means diesel is going to be here. So diesel is supplied with the help of fuel supply pump or fuel feed pump, and the fuel will pass through a fuel oil filter, right, where the debris are going to be removed, and the filtered diesel is going to enter into fuel injection pump. So there are two pumps. One is fuel supply pump and other one is fuel injection pump. Okay. So now the fuel injection pump. Hello, please mute yourself. I think a lot of noises are coming. Please mute your audio. Yeah. So now the fuel from the fuel tank, with the help of the fuel feed pump, it passes through the fuel filter, and the filtered fuel enters into the fuel injection pump, right? So in the fuel injection pump, we will be having a plunger arrangement. This pump has a plunger, and that plunger will push the fuel again. So here in this region, we will be having low pressure fuel, and at the exit of the fuel injection pump, we will be having high pressure fuel. So that high pressure fuel enters into the fuel injector or fuel nozzle, right? So and it is sprayed into the engine cylinder. Into the engine cylinder, the fuel is sprayed. Okay. So now when the high pressure fuel reaches the fuel injector, there is a return line, right? Only during just before the power stroke, fuel is going to be injected. During the rest of the time period, whatever fuel that is going to enter the fuel injector, it has to return back to the fuel oil tank. Okay, so it will come back to the fuel oil tank. So in the case of fuel injection system of a CA engine, so the following are the components that are available. We will have a fuel tank. Then there are two pumps available. One pump we call it as fuel supply pump or fuel feed pump, and the other pump we call it as fuel injection pump or fuel pump. Just you can call it as fuel pump or fuel injection pump. Okay, and this system also has a fuel oil filter, and a governor is necessary because depending upon the load and depending upon the RPM of the engine, the quantity of fuel that has to be supplied, that is going to be varied. So we need to have a governor. So governor will provide the amount of fuel that is to be injected into the engine cylinder. And finally a injector. So to spray the fuel into the engine cylinder, we need to have a fuel injector or a fuel nozzle. So this is the schematic sketch of the fuel injection system in the case of a CA engine. Now, so when we inject fuel into the engine cylinder, right, in the case of a CA engine, what are the various requirements, right? So the various requirements are like this. We have to determine what is the quantity of fuel that has to be injected. Okay, depending upon the speed and depending upon the load on the engine, the quantity of fuel that has to be injected has to be monitored, has to be metered. Okay, so that is one purpose of the fuel injection system's main purpose is that the quantity of fuel that is going to be injected, that depends upon the speed of the engine as well as the load on the engine. And when we are going to inject this fuel, that injection timing is also important, right? So just before the end of the combustion, we have to inject the fuel. So fuel injection timing is very important. And this is similar to in the case of SI engine, we used to introduce the spark. Here we are going to inject the fuel. All right. So this is similar to spark timing in the case of SI engine. And the rate at which we are going to inject the fuel, right? The time period, right? How long it is going to be injected and how much quantity. So that is also an important parameter. And when we inject the fuel, the injection profile is very, very important. The spray pattern of fuel injection, that is very, very important, because based on that only the rate of energy release is going to be there, and the emission from the engines are going to be there because of the due to the fuel spray pattern. It depends upon the fuel spray pattern. Okay. So and it also depends upon the size of the droplet, because we want to have proper atomization. The smaller the size, the finer the fuel that is being injected, then the atomization is going to be better. Okay, so it depends upon the droplet size and the penetration depth, to what extent in the axial direction the fuel sprayed is going to travel, right? So it depends upon the penetration of the fuel when it is being injected. So at very high pressure we are going to inject, and it is going to penetrate through the air fuel mixture, or it is going to enter into the air, and then thereby it is going to have the mixing of the air fuel, and combustion is going to occur. And also to what extent it is going to disperse, right, radially inside the engine cylinder, right? Penetration is it is going to pass through in the axial direction, to what extent it is going to travel, and dispersion is in the lateral direction or in the radial direction, to what extent the fuel is going to spray, right? So these are the parameters that are responsible for complete combustion, right? So a proper spray structure is necessary. And also remember, when we spray the fuel, two things we should remember. The fuel should not wet the wall. The cylinder wall, it should not wet. Okay, the droplet should not reach to the cylinder walls, right? That is one parameter. And the other parameter is that it should not be leaking. So the fuel droplet should be atomized, right? It should be in the vapor form. It should be atomized. It should not be in the liquid state. It should not be dripping. So these are the things which has to be considered by the fuel injection system for proper combustion and to provide more power output from the engine. And also, if it is the engine is going to be a multi-cylinder engine, and to each and every cylinder there should be proper distribution of fuel to the every engine cylinder. Okay, in the case of multi-cylinder engine. So these are the parameters that are to be taken care by the fuel injection system in a CI engine. Okay. Now coming to the classifications of fuel injection system, basically there are two classifications of fuel injection system. One we call it as air injection system, and other one is airless injection or solid injection system. But this air injection system is very old, and these days we don't use. This is obsolete now. Okay, this is not in use right now. So in the case of air injection system, compressed air is used for supplying the fuel. Right? In the olden days, they used to have compressed air. That means there will be a compressor, right, which is driven by the power received from the engine itself. Okay, a compressor is going to be mounted, and to drive the compressor, power will be taken from the engine crankshaft. Okay, and that compressed air is going to spray fuel into the engine cylinder for combustion. So as a result, what will happen, since compressor is going to be mounted, the size of the engine is going to be very big. Okay, so engine weight is going to increase, and since it is going to take the power from the engine crankshaft, we are going to have reduced brake power. So the power output is going to be less, and engine size and weight is going to be more. And since we are having the advantage of the air injection system is that since air and fuel are compressed air and fuel are added, the better mixing of the fuel and air is possible. And since there is a better mixing of air fuel mixture, the mean effective pressure is going to be higher. So this is the advantage. And we can use fuels of low grade quality or fuels of very high viscosity. And if you go for low grade fuel or highly viscous fuel, then the fuel cost is going to be less. It is going to be less expensive. So less expensive fuels can be used. These are the advantages we are going to for air injection system, right? But since it is heavy, engine size is going to be bigger, and the weight of the engine is going to increase, and the power output is going to be less, and we stopped using this air injection type of fuel injection. Okay. So then we started using the airless injection or solid injection, where air alone enters and there is no compressed air, Only air is entered and the compression takes place because of the movement of the piston during the compression stroke, and the fuel is directly injected into the engine cylinder. Okay, so airless injection is what we are using these days. So there is no compressed air. Okay, so coming to the airless injection or solid injection, the fuel, there are two pumps. One is fuel supply pump or fuel feed pump, and the other pump is called fuel injection pump, right? So when we say in general fuel pump, it refers to the fuel injection pump. So I have told you that this fuel injection pump works with the help of a plunger arrangement. So that is what is shown in this diagram here. So the fuel from the fuel tank, and with the help of the fuel supply pump, it passes through the fuel filter, and then it enters into the fuel injection pump. This is the fuel injection pump. This is the inlet port through which the fuel is going to enter. So here we are going to have low pressure fuel oil. When it enters into the fuel pump or fuel injection pump, the pressure has to be increased tremendously. That is taken care by the plunger arrangement. This is the plunger arrangement. So this plunger is going to move up. When it moves up, its pressure is going to be increased, and as it moves, these two ports are going to be closed. This spill port and the inlet port are going to be closed, and the pressure is going to be increased. As the pressure reaches a predetermined value, this delivery valve opens. This is a spring-loaded delivery valve. This valve opens. So high pressure fuel is going to be supplied to the fuel injector. So through this port, through the delivery port, the high pressure fuel is going to be supplied. High pressure diesel is going to be supplied to the fuel injector. And the movement of the plunger, this is done by the cam. So a camshaft will be there, and in the camshaft a cam is arranged, and cam and follower arrangement is there. So this follower is connected to the plunger, okay, with the help of a spring. So as the cam moves up, right, when it makes the plunger to move up, it is going to act against the spring pressure. So it has to overcome the spring pressure, and it has to exert the pressure in the plunger. So thereby the fuel is at high pressure, it is going to be injected into the fuel injector. It is going to be supplied to the fuel injector. Okay. So when the cam comes to the dwell period, this we call as a dwell period. During the dwelling period, so the follower will come down because of the spring action. Okay. So during the ascent period, when the cam moves, and during the ascent period, it is going to push the follower, and thereby it is going to make the plunger to move up. Thereby high pressure is going to be created, and the high pressure fuel diesel is supplied to the fuel injector. Okay, this is how the fuel injection pump works. Coming to the different types of solid injection, right, or airless injection. So these days we are having only airless injection or solid injection. So we have various arrangements of the pump and the injector. The order in which we are going to arrange the pump and injector to the engine cylinder, right? So based on that, we have some 4 different types of fuel supply system in the CI engine. One we call it as individual pump and nozzle system. That means like for each and every cylinder, there will be a dedicated fuel injection pump and a fuel nozzle or fuel injector. So that will be there for each and every engine cylinder. And the other one is called unit injector system, where the fuel injection pump and the fuel nozzle both will be single unit. Right, as a single unit it will be available. That we call it as unit injector system. There will be a dedicated unit for each and every cylinder. Okay. Then we have a distributor system. So in the case of distributor system, we will be having a rotary mechanism. So it will allow the fuel to the different cylinders of the engine. Right. And this is like the in the case of SI engine, when to supply the power to the spark plug, we used to have a distribution system. No? Similar to that, here we are going to supply the fuel. And the last one and the latest one is the common rail direct injection system. Okay, so basically there are 4 different types of systems available. Coming to the individual pump and nozzle system. So here if you see in the diagram, we have shown 2 cylinders, cylinder 1 and cylinder 2. So cylinder 1 is having a fuel injector and a high pressure pump, which is nothing but the fuel injection pump. Cylinder 2 is having a dedicated fuel injector and a high pressure pump or fuel injection pump. So a separate fuel injection pump and fuel nozzle or fuel injector are available for each and every cylinder. Okay. So now this is the fuel supply from the fuel supply pump. It passes through the fuel oil filter, and it comes to the high pressure pump or the fuel injection pump. Okay, so there is a separate pump for each and every cylinder. Okay, now so in the case of individual pump and nozzle system, so every cylinder is provided with a separate fuel injection pump and injector. And the fuel pump, this pump, high pressure pump or fuel injection pump, this is actuated by a plunger, right? In the previous diagram, I have shown you the plunger, right? So that plunger is activated by a cam follower arrangement, and this supplies the fuel at sufficient pressure to open the injector. So the injector will not open very easily. So only when you are going to supply fuel at very high pressure, the injector will open, and thereby it is going to spray the fuel in the engine cylinder. Okay, so and there are one more arrangement within the individual pump and nozzle system. There is one more arrangement where these pumps, they are not separated, but it is going to be together, but two different pumps will be there and they will be together. This we call it as cluster arrangement. So this type of fuel supply system we call it as cluster arrangement. There are two pumps, but both are placed together, and these two pumps are high pressure pumps, and this is also called as fuel injection pump. So the fuel from the fuel supply pump, which is at a lower pressure, passes through the fuel oil filter, and it comes to the high pressure pump. From the pump, it is going to the individual injectors that are present in the each and every cylinder of the engine. Okay, so this is what is individual pump and nozzle system. I'll show you one more diagram for this. So here you can see fuel from the fuel oil tank passes through the low pressure pump, which is a fuel supply pump, and it comes to the high pressure pump. So separate pump for separate cylinders for the individual cylinders. So this is the high pressure line. Okay, so the high pressure line, it comes to the fuel injector. Okay, so this is the individual pump and nozzle system arrangement where the pumps are separate. If it is a cluster type, so the fuel from the fuel oil tank comes to the low pressure pump or fuel supply pump, then it passes through a filter, then it comes to this pumps. These two pumps are high pressure pumps or cluster. And remember, even though the casing is one casing, but the pumps are different. So this is for cylinder 1 and this is for cylinder 2, and it is going to inject the fuel in the fuel injector. Coming to the next type of fuel injection system, which we call it as unit injector system. In the case of unit injector system, the high pressure pump, fuel injection pump and fuel injector are as a single unit. It is going to be there as a single unit. So this indicates the fuel injector and pump. Both are placed here together. For every cylinder, you will find a separate pump and the injector, but these two are available as a single unit. So there will be one unit per cylinder, and this is very compact. And here there is no high pressure line, because in the earlier case, after the high pressure pump, there will be a pipeline which connects the fuel injector. Now both are placed together, so there is no high pressure line. So the amount of fuel injected depends upon the stroke at which the piston is going to move. This plunger is going to move. Okay, that determines the amount of fuel that we are going to inject into the engine cylinder. So this is suitable for electronic fuel injection system, for electronic control system. So this type of unit injection system are convenient. So here there is another diagram for the unit injector system. So the fuel from the fuel supply pump, right? It is going to pass and here, so it is getting divided into two for the two cylinders, and it enters into the unit. Unit means both fuel pump and injector are together. Okay, there is two different fuel injector and fuel pump together. Okay, so this is a return line, so through which the fuel comes back to the fuel oil tank. Okay, so there is only low pressure line and there is no high pressure pipeline in the case of unit injector system. So coming to the distributor system, third type of fuel supply system in CA engine is distributor system. So this is a distributor. Okay, so the fuel from the fuel tank with the help of the low pressure pump or fuel supply pump passes through the fuel oil filter. From the fuel oil filter, it comes to the distributor pump. So here, so the metering and the pumping, everything is done by this distributor. Okay, so depending upon the timing, okay, it will supply fuel to the cylinder 1 and then to the cylinder 2, right? So will show you one better diagram for this, and I will also show you a video. So in the case of distributor injection system, the high pressure pump, this high pressure pump, okay, everything is together, this high pressure pump and then this distribution rotating system, okay. This does the metering and pressurizing and the timing at which the fuel has to be supplied to the each and every cylinder. Everything is taken care by the distributor pump. This we call as a distributor pump. So it has a rotary mechanism to supply equal quantity of fuel to each cylinder at the appropriate time, okay. And this rotary system, it has a rotor and a stator, and the rotor has radial holes. I'll show you when you see the video, it will be clear, right? So the radial holes will align with the inlet and the outlet ports, right? Thereby it allows the fuel from the fuel oil pump and to the fuel injector of the corresponding cylinder. So the pumping action is because of the plunger that is rotating inside a cam ring. This is a completely entirely different setup. So when you see the video, it will be very clear. So I will show you the video for this. Yeah, this is, so this is distributor type fuel injection system. Okay. So this is the rotating part. Okay. And this rotating part has holes, radial holes. So this is the plunger part. This is the plunger part. So this hole you can see, it is going to get aligned, right? Now let us say this is the fuel oil inlet line. Okay, when the hole aligns, yeah, this is the rotor part which has holes. This is for fuel inlet and this is for fuel outlet. So this is the plunger arrangement which exerts the pressure, and thereby the high pressure diesel is going to pass through this longitudinal cavity, and it is going to come out through the outlet port. So this will go to the injector part. This is fuel inlet line. This is fuel inlet port. Because of the rotation of this plunger inside the cam ring, this we call as cam ring. As it rotates, when the hole aligns, then the fuel enters, and when the hole aligns here, then the fuel comes out. So this is what we call it as a distributor system, distributed fuel injection system. Okay, so here also we are going to have a low pressure pump, and then the outlet from the low pressure pump or the fuel supply pump goes to the distributor. So this distributor has both rotating part and the stator part. In the rotating part we are going to have holes, and when the holes align properly, fuel intake and the fuel pumping are going to take place. When it is going to pump out the fuel, it is going to come to the fuel injector of the engine cylinder. So this is distributor injection system. And the last one is common rail fuel injection system. So in this case, so we will have a low pressure pump will be there. Low pressure pump is nothing but the fuel oil supply pump, which will supply fuel to the high pressure pump. And the outlet of the high pressure pump, or this high pressure fuel pump, it will supply fuel to a common header or a common rail. A common pipeline will be there. In this common pipeline, the fuel will be at a higher pressure always, right? So as the depending upon the timing of the injector, the fuel is going to enter into the corresponding cylinder. So the high pressure in the header, that is going to force the fuel to pass through the fuel injector, okay, or the fuel nozzle. So the injection timing and duration are controlled by there is one more valve called injection valve. Within the fuel injector, we will have a valve called fuel injection valve. So that is going to be operated by, there are two mechanisms by which we can operate this fuel injection valve. either by a mechanical means, or we can have a electronic operating system. If it is a mechanical system, then you will find a push rod and rocker-arm arrangement. So that is going to open the fuel injection valve, and thereby it is going to allow the high pressure fuel to enter into the fuel injector, and it is going to spray it in the engine cylinder. Otherwise, we will be having a solenoid valve which is going to be operated by a electronic control unit. So here you can see. So in the case of the common rail direct injection system, CRDI, this we call it as a CRDI. Most of the Hyundai cars you will find this CRDI. Okay, so this is a fuel oil tank, right, or the diesel tank. The fuel from the diesel tank, with the help of a fuel pump, as it passes through the fuel filter, it is going to be supplied to the high pressure pump. So this is low pressure pump, and this is the high pressure pump. So this high pressure pump will supply fuel, high pressure fuel, into a common rail. This we call as a common rail or a header, common header. Okay, so there is a pressure relief valve. If the pressure is very high, then it is going to release, and the fuel oil is going to come back to the fuel oil storage tank or the diesel tank. It will come back to the fuel oil tank. Okay, so now when the common rail, high pressure fuel is present. Now let us say this cylinder is going to fire. Assume that cylinder 1 is going to fire. So then the fuel injector is going to be opened. Here this has a fuel injection valve. If it is electronic, it can be operated electronically or mechanically. If it is going to be mechanically operated, then we are going to have a push rod and rocker arm arrangement. If it is electronic arrangement, then solenoid valve will be there. Then this injection valve will open. So this high pressure fuel, it is going to enter into the fuel injector, and it is going to be sprayed. Okay. So this opening of the injection valve is regulated by a engine control unit. So depending upon the throttle position, depending upon the manifold pressure, right, and depending upon the temperature sensor and the speed of the engine. So these are the parameters based on which this fuel is going to be injected, and the quantity of the fuel is going to be regulated. Okay. So for this also we have a small video. I'll show you that video. So this is about common rail. This is about CRDI injection. So this is common rail. So here we'll be having high pressure diesel always. So pressure is 20,000 psi. CRDI consists of a common rail, a fuel tank, a fuel filter, electronic fuel pump, electronic control unit, sensors, and injectors. Now let's see how a typical CRDI system looks like. The fuel tank is connected to the fuel filter, which in turn is fuel tank connected to the fuel pump through a fuel filter. The high pressure pump is in connection with the common rail that connects individual injectors. The injectors in turn are connected with an electronic control unit, which is fed by the throttle position sensor, manifold pressure sensor, speed sensor, and the temperature sensor. The common rail is attached with a pressure sensor connected to the ECU and a pressure relief valve connected to the fuel tank. The fuel stored in the fuel tank is fed to the filter and is then pumped by the fuel pump. The high pressure pump further increases the pressure of the fuel. On receiving the signals from the pressure sensor, the ECU controls the pressure regulating valve to supply the required amount of fuel. The pressurized fuel from the pump reaches the common rail, which acts as a pressure accumulator and sends the fuel to the individual injectors. If excess pressure gets created in the rail, the pressure control valve will release fuel back to the tank. The ECU detects the engine conditions on receiving signals from the sensors and controls the injectors for injecting the correct quantity of fuel at the correct time. Thus, the fuel gets injected
injected into the cylinders at higher pressure based on the requirements. Now, this is how the CRDI works. As the injection is controlled electronically, this system is superior.
So that's about this CRDI injection. So coming to the comparison between the various types of solid injection in a diesel engine. So these are the parameters we are going to discuss about if it is an individual pump and injector system, if it is a distribution injection system, if it is a common rail direct injection system, how the system is going to vary during the various process of fuel injection. While how to regulate the amount of fuel that is being supplied. So in the case of individual pump and injector system, so we have a fuel pump, right? This high pressure pump. Okay, so that high pressure pump is going to regulate the amount of fuel that is going to be supplied. In the case of distribution system also, we are having that plunger pump, right? The rotary part. So that is going to regulate. And in the case of common rail direct injection system, so a separate injection valve is there. That is controlled by the ECU. Okay, so that is going to regulate the amount of fuel that is going to be supplied. And coming to the timing, when to supply the fuel. So that is done by a cam. In the case of individual pump and injector system, so we will be having the plunger cam. Okay, so that plunger cam movement, that is by a cam. Okay, the plunger movement is the plunger that is present in the fuel pump, that is driven by a cam. So that cam is responsible for the timing. And in the case of distribution injection system, so inside the cam ring, right, the plunger, it is going to move the profile of the cam ring. So that is going to be the timing for fuel injection. And for a mechanical system of common rail direct injection system, the push rod and the rocker arm, so that arrangement is driven by a cam. Okay, so that cam is responsible for the fuel injection timing. And if it is an electronic control, then ECU is responsible for the timing of the fuel injection. And the rate of injection. So that for individual pump and injector system, it is going to be again by the cam, which is going to drive the plunger of the fuel pump. And here it is the distribution pump. And the injection rate depends upon the spray valve. Okay, fuel injector has a spray valve. So that is what is responsible for the fuel injection rate in the common rail injection system. Whereas atomization, in all the cases, it depends upon the spray tip. At the nozzle tip, the profile of the spray tip, that is going to determine the atomization. And the distribution of the fuel sprayed, so that also depends upon the spray tip. So these are the comparisons of all the different fuel injection systems found in the CI engine. Okay. So that's all for today's lecture. So in the next lecture, we are going to discuss about the various spray structures and its associated terminologies. So that's all for today. Hello? Hello, am I audible?
Yes, sir. Yes, sir.
Yeah, okay. So I think like you have seen my message